Hey Algebra 1, so we're on page 249 of the binder. We're going to talk about factoring. So actually the rest of this chapter is really going to focus on this thing called factoring. And if you remember back in middle school, we talked about the word factors. All right, or you talked about the word factors. And factors are the things that make up a multiplication problem. So if I said, what are the factors of 6? Okay, you would say 1, 2, 3, and 6, right? Any number that multiplies to 6. Okay, one thing so when we talk about factoring, what is factoring? Factoring is the process of breaking down an expression into factors. Okay, and so one of the things I'm going to repeat in class a lot is what's your job? And your job is to create a multiplication problem. All right, so when you see factoring, you're going to think, what's my job? And it's create a multiplication problem. Okay, so something that's not a multiplication problem, we're going to turn into a multiplication problem. All right, so another thing is splitting it up into multiplication, and we're kind of, and the way we go about doing this is we're really undoing multiplication, we're undoing multiplication. So in this unit, there's a lot of different types of factorings that we're going to be able to do. This first section of notes is about something called the greatest common factor, and it will always be our first step when we do factoring problems. We will always look for a greatest common factor first. Okay, so in this box has an example. All right, I actually want to start down here with example 1. Okay, so the greatest common factor means literally what's the biggest number that is common. So greatest means biggest. Common means it's for both of them. And then factor means something that multiplies. So for part A here, the factors of 12, we're going to write those down. All right, the factors of 12 would be 1 and 12, 2 and 6, 3 and 4. Okay, the factors of 28 are 1 and 28, 2 and 14, not 3, not 4 and 7, and that's it. So what is the biggest number in those two lists that they both have in common? And the answer to that is 4. So the GCF, the greatest common factor, is 4. So now, usually you don't have to go through this whole process of writing the list out. And then sometimes what you can do, so for part B, just look at the smaller number, because there's no way it can be a number bigger than the smaller number for the greatest common factor. So if we look at 18, I could write 1 and 18, 2 and 9, 3 and 6. Okay, and I'm looking for any of those numbers, the biggest number that goes into 54. Well, actually 18 goes into 54, so my GCF here is 18. 6, 15, and 21 for part C. Now I'm looking for what number goes into all three of those, right? Again, it can't be any bigger than the smallest one. So I look at 6, 1 and 6, 2 and 3. And you just go from the biggest one. Does 6 go into 15? No. Does 3 go into 15? Yes. Does 3 go into 21? Yes. So 3 is my answer. Okay. Now, when we throw in a variable, all right, there's two different things we're looking for. We do the GCF of the number, and we do the GCF of the variables separately. Okay? So in D, 4x squared and 10x, when I look at the GCF of the numbers, for 4, it's 1 and 4, 2 and 2. The biggest number that goes into 10 is 2. So the GCF of the number is 2. And then x squared and x. Okay, when we get into variables, you're basically taking the smaller exponent of a shared variable. So x squared and x, okay, I could take out, we say take out, the GCF is x, okay? And a way to think about this is x squared is really just x times x. X is just x. So what is the most amount of x's that they have in common? Is 1. So I can take out 1x. So my GCF for part D is 2x. For part E, 3x cubed and 7x. Well, if I look at 3, my factors of 3 are 1 and 3. Remember, you look at the numbers separate from the letters. Well, 1 and 3, neither of those go into 7. So my greatest, well, 3 doesn't go into 7. 1 does. That's the greatest common factor for the number. For the variables, x cubed and x, now I have x times x times x for x cubed, x for 7x. So the most they have in common is one of those. So my letter GCF is x. Okay. Part F, 12, 42, and 6. Go with the smaller one. So the smallest number first. So 6, 1 and 6, 2 and 3. And you just kind of work your way down. Does 6 go into 12? Yes. Does 6 go into 42? 6 times 7 is 42. So it does. So my GCF of the numbers is 6. Then for the variables, I have x squared, I have x, and I have nothing. Okay, well, I can't take something out of, I can't take something out of all 3 because there's nothing in the third, no x in the third term to take out. So there is none. So there's nothing to put there. So my GCF there is just 6. Okay. All right, so now let's see what this looks like in some examples, problems. So part A, example 2, part A. Factor out the greatest common factor. And that's kind of the terminology we use, factor out. Because what we're going to end up with is really the reverse of a distributive property problem. Okay? We're going to end up with something and then parentheses. All right? Now when you look at that original problem, I have 3 terms. So when I make my parentheses, when I'm done, I should have parentheses with 3 terms in it. Okay, after we do a couple, you'll start to see the pattern here. So I'm looking for the GCF of the number first. So I have 4, 24, and 2. Okay, so the biggest number that goes into all 3 of those is 2. So I write that out front. We put the GCF in front. Okay, in fact, GCF times parentheses. Okay, and then I look at the letters. Here I have x to the 4th. Here I have x to the 3rd. Here I have x squared. So I take the smallest exponent out, x squared, because that's what those have in common. So x squared. I could take out x squared from all 3 terms. So I get that, and now I'm going to put my parentheses. And I know I need 3 terms in the parentheses because I started with 3 terms. So then I just figure out what's left over after I've divided out or taken out the GCF. And I think the best way to do that is to imagine distributing back. Okay, I need to figure out, for my first term, 2 times what would equal 4? And it's 2. And then x squared times what would equal x to the 4th? It's x squared. So, notice 2x squared times 2x squared is 4x to the 4th. So I get my original back if I distribute it. All right, then I have 2 times what equals 24. It'd be 12, so I write plus 12. And then x squared times what equals x cubed, or I took out x squared, so I'm left with 1x left over. So 12x. And then here, 2x squared times what would equal negative 2x squared? Okay, well, times negative 1 would equal that. And so here is my final factored answer. And what I've done is I've created a multiplication problem. 2x squared times 2x squared plus 12x minus 1. We say we took out the GCF, the greatest common factor. All right, so now this is a problem we call it in factored form. Okay, let's look at B. All right, these will start to go a little faster as we get more used to this. So I know I need this format here, GCF times parentheses. There's 3 terms, so I'm going to need 3 terms in my parentheses. So let's see what we can take out. From the numbers, 8, 12, 24, 4 goes into all of them. So I get to take out 4. And then I have y squared, y, and nothing. I can't take a variable out. I can't take y out because 24 doesn't have a y to take out. So I'm just go straight to my parentheses. Right? So then here I'm thinking about distributing back. 4 times what gives me 8y squared? It would be 2y squared. See how that works? 4 times 2y squared would be 8y squared. Then I'm going to have 4 times what equals negative 12y? It would be negative 3y. And plus 4 times what equals 24? 6. Okay, there's my answer. Okay, you can always check by distributing back. Okay, so check. We could distribute back 4 times 2y squared is 8y squared, 4 times negative 3y is negative 12y, and 4 times 6 is 24, right? That matches the original, so I got it right. But notice my answer is what's boxed in. All right, finally, almost done here, part C. Negative 16x squared minus 16, okay? The number they have in common is negative 16. Okay, so that's my number that goes in front of the parentheses, okay? And what goes inside is what's left over. So negative 16 times x squared would give me negative 16x squared, and then I would need to multiply negative 16 times positive 1 to get negative 16 there. Notice I distribute it back, okay? So that's my answer there. One little note to put below this. If the leading coefficient is negative, factor out a negative number. Okay, so if that leading coefficient is negative, we always factor out a negative. All right, we'll get a lot of practice with this in class, and thanks for watching.